Hello everyone, welcome back to the course on machine learning using Python programming. In today's lecture, we will see fuzzy C-means clustering. In the previous lectures, we have seen K-means clustering, then K-means plus plus clustering and hierarchical clustering. So, all those clustering algorithms were hard clustering algorithms in the sense that in these clustering algorithms, as a result when we get clusters, so one data point can belong to only one cluster, while in case of fuzzy C-means clustering there are chances that one point can belong to more than one clusters. Definitely we will have some membership values for different clusters for a particular point, and that membership value will give you you can say the probability of belonging to that particular cluster. So, let us see this fuzzy C-means clustering in detail. So, here fuzzy C-means clustering allows each data point to belong to multiple clusters with varying degree of membership, while in case of K-means clustering or hierarchical clustering, we have seen the one data point can belong to only one cluster. So, what is similarity between K-means clustering and fuzzy C-means clustering or any other partitioning hierarchical clustering? So, here it aims to partition a set of n dimensional data points into a predefined number of clusters. So, we can say that in both of these two algorithms or any clustering algorithms that we have seen so far. So, in these clustering algorithms the whole data set is divided into predefined number of clusters, and the same thing is done in fuzzy C-means clustering also. And now we will see what is difference between fuzzy C-means clustering and the clustering algorithms that we have seen so far. So, difference is that each point is assigned a membership grade for each cluster rather than being assigned to a single cluster that we have done in the previous clustering. So, here each point can belong to more than one clusters and with some membership grade or with some membership degree. So, you can say that point number 1 is belonging to cluster number 1 with membership degree 0.1, and it is belonging to cluster 5 with the membership degree 0.9, and in the rest of the clusters its membership value will be 0. So, this is the main difference, and that is why it is called as fuzzy C-means clustering. So, it is not hard clustering. Here one point can belong to more than one clusters with different membership values. So, now we will see the working of fuzzy C-means algorithm. So, in the first step, definitely we will need to choose the number of clusters that we want as a final result. So, we will need to choose, we will find we have seen so many methods for finding optimal number of clusters, or we can guess it and we can decide for number of clusters, that is C. And here we have one model parameter that is called as fuzziness parameter. So, it is denoted as M, and this fuzziness parameter determines degree of fuzziness in the clustering. Its range is 1.5 to 2.5. So, this fuzziness parameter is giving you degree of fuzziness. So, if we will keep the value of M low, in that case it will be this fuzzy C-means clustering will be corresponding to hard clustering, and when this degree of fuzziness is large, in that case it will be like fuzzy C-means clustering. In that case your fuzziness will be more, means there are chances that one point may belong to more than one clusters with different membership degree, while if we will keep this degree of fuzziness low, in that case one point will belong to only one cluster, or it will correspond to the hard clustering algorithm. So, after initializing values of C and M, we will need to initialize centers of the clusters. So, this we will do randomly, or we can use as we have done in case of k-means plus plus algorithm, the first centroid or first cluster center we decided randomly, but rest of the centers we used one method, through that we calculated the remaining cluster centers. So, we can choose any of these two methods, but we will we should find out cluster centers for each cluster that we have decided. So, after finding these cluster centers, we will need to calculate membership grade of each point for each cluster using this formula. So, till now suppose if we want only 2 clusters, so in that case if they are suppose 10 points, so for all these 10 points we will need to find out membership grade of these points to each cluster, cluster number 1 and cluster number 2. So, it means we can say that U11, U21, U31 up to U101. So, this is the membership grade of all the data points for cluster number 1. In the same way, U12, U22, U32 and so on, U102, all these are membership grade of different data points for the second cluster. So, in this way we will calculate membership grade for each data point for all the clusters. So, what is the formula? Let us understand it. This is 1 upon xi minus vj upon xi minus vk, and then we are taking summation over k is equal to 1 to c, where c is the number of clusters. So, it means for ith data point we want to calculate membership for jth cluster. So, for ith point and jth cluster we are finding membership grade of ith data point for jth cluster. So, for that we are taking xi minus vj. So, distance of this data point, ith data point with the centroid of jth cluster upon distance of ith data point with the first cluster, centroid of the first cluster plus ith data point and second cluster distance plus distance of ith point and third cluster and so on. So, we will take power of this term. So, that power is containing, you see this m, that is the fuzziness parameter. So, using this formula we can find out membership grade for each data point for all the clusters, and after finding these membership values, then we will update cluster centers. So, how we will update cluster centers? We will use membership grades that we calculated in the previous step. Using those membership grades, we will update these cluster centers. So, now you see, if we are having C clusters, so we will calculate Vj, that is the center of the jth cluster. So, this we will do for V1, V2 up to Vc. So, Vj, how we are calculating center of the jth cluster? So, it is equal to summation of Uij to the power m xi upon summation of Uij to the power m. So, what is Uij? So, this is for all I. So, if there are n data points, so for all data point we are multiplying that data point value with membership of that data point for this jth cluster to the power m. So, in this, and then we are taking summation over all instances. So, for the second instance what is the membership value of that instance for jth cluster. So, in this way we will get the numerator, and then in the denominator we are having uij to the power m, where I is from 1 to n. So, in this way we will find out the centroid of the jth cluster, and we can use the same formula for finding, for updating centroid of different clusters. So, when we will update, we will get the updated centroids of the clusters. We will again update membership values of different points for different clusters using this same formula, and after updating these membership values of different points for different clusters, we will again update cluster centers using this formula, and these two steps we will repeat until these membership grades converge to a stable values. Means we can say that your membership values will not change, or there may be some other termination criteria also. You can fix some number of iterations. So, after that you will stop, or you will check the clusters that are formed, the quality of those clusters are up to some particular level. So, we can decide some threshold, and then we will calculate Shillert coefficient, and then we, based on that, we can stop the process here. So, after this, when we will stop the process, then whatever membership values we have at that step, so then how we will finally form the clusters, we will assign each data point to the cluster with the highest membership grade. So, after this step you will get finally hard clusters, means now you assigned a point to the cluster for which its membership value was the maximum. So, in this way the fuzzy C-means algorithm works, and let us see one example. So, in this example, suppose we have 10 data points, and your data set is 2-dimensional data set. So, these are the 10 data points in your data set. So, and we want to cluster this data set in 2 clusters using fuzzy C-means clustering algorithm. So, we will need to take 2 values C and M. So, C is already given, C is 2, and M we are taking suppose 2, M is again 2. So, and we are fixing here the termination criteria is number of iterations. So, that is we are taking as 10. So, the first step is we need to initialize cluster centers randomly. So, your cluster centers, since we are we want finally 2 clusters. So, we will take 2 points as a cluster centers, and we are assuming 2 2 and 4 2. These 2 points we are assuming as a cluster centers. So, after deciding centroid of these 2 clusters, we will need to calculate distance between each data point and these cluster centers. So, we can take any distance, we can use Euclidean distance also. So, after calculating these distances, so distance of this point with this centroid, this point with this centroid, this point with this centroid, and so on. In the same way, distance of all these points with this centroid. So, after calculating this, we will calculate membership grade. So, for that membership grade, we have already seen the formula, and that is why we find out we calculated distance between point and centroid, because here we are using distance between point and centroids of different clusters, and these we have already calculated. So, using this formula we will calculate membership grade of each point for each cluster, for both of these 2 clusters. So, after this, suppose these are the membership values we are getting for all 10 data points. So, we can say that for first point, membership grade for the first cluster is 0.528, while membership grade for cluster 2 is 0.472. So, here we can say that although there is not much difference, but there are more chances that means using membership value, if we want to assign 0.1 to any of these clusters, we will assign it to cluster 1. For any cluster, if it is more here, it is not for any of these clusters, this difference is not much. So, after calculating membership grade for each data point for all the clusters, we will need to calculate new cluster centers. So, how we will calculate new cluster centers? Using these membership values. So, new cluster centers we will calculate using this formula. These membership values we are having and all the data points we are having. So, using this formula we will calculate new clusters. So, new cluster centers. So, suppose these are the, when we will calculate, we will put these values in that formula, these are the new cluster centers that we will get, and then we will repeat these two steps for 10 iterations, because our termination criteria here we have taken as 10 iterations. So, after 10 iterations, suppose this is the membership values for all data points for these two clusters, and this is the new centers of the two clusters. So, here after 10 iterations we will stop, but our final result should be number of, means actual clusters, actual two clusters, not the membership values and so on. So, now we can see here for data point 1, membership value for cluster 1 is 0.756 and for cluster 2 is 0.244. So, this membership value is much higher than this, and that is why we will assign first data point to the first cluster, second data point also to the first cluster because its membership value is greater than this, third data point also to the first cluster, this also. So, but here you see this data point, sixth data point, for this 6th data point membership value of the second cluster is high. So, that is why we will assign this 6th data point to the second cluster, and 7th point also to the second cluster, 8th point also to the second cluster, and so on. So, in this way our clusters will be formed using fuzzy C-means clustering, and I hope understood the process of fuzzy C-means clustering. Here in several iterations we are changing the membership value of each data point for different clusters, and then using these membership values we are changing the cluster centroids. When centroids are changed, means clusters centroids are changed. So, again we will need to calculate membership values for all the data points for both of these two new clusters, because their centroids are changed now. So, when these membership values will be updated, then we, based on these membership values we will found new cluster centroids, and this we will do until we are getting we can say that we are getting good clusters, or your convergence occurs, or number of iterations suppose are reached to the point that we decide and that we defined, or any way of if the termination criteria is meeting, then you will stop at that point, and then based on the membership degree you will assign different points to the corresponding clusters. So, this is the fuzzy C-means clustering, and till now we have seen K-means and then K-means plus plus, hierarchical clustering and fuzzy C-means clustering algorithm. So, I am stopping here. Thank you.